guys, welcome to IngenMinds, and in today's video we're going to be talking about functions. Particularly we're going to be talking about the parabolic function, the continuation of it, because in our previous video we talked about function basics and the properties and the parameters of a function. And if you've missed that video, the link is down in the description. Do check that video out, get acquainted with the basics, so that you'll catch up with us in this video. My students actually asked me to approach this video from a student perspective, like preparing for an examination. And it actually got to me that what would I do if I went back and I said I wanted to prepare for an examination, or prepare for the end term exam, or any exam, or just prepare myself regarding this topic called functions. Okay, now when we go to the parabola, like I said, I'm going to start at the sketch first. What do we know about the parabolic function? We know that the parabolic function has an x-intercept. I'm just going to write x-int right there. And we also know that the parabolic function has a y-intercept. And we also know that it has a turning point. Don't mind my handwriting right there. And we also know that it has an axis of symmetry. And this is all we need to know regarding sketching. The other properties like domain and range, we're going to talk about that at the end of after we sketched the function first. Okay, now what do we do first? We first go for the x-intercepts, and I think the reason why I actually suggest we should go for the x-intercepts, remember that when you go from algebra, you transition into functions. So I think it's best to pick up where you left off. I know you were substituting, doing that, finding the y, finding roots and all that, but just start at the x-intercepts. Unless in an examination maybe you ask something different, or maybe you ask something different entirely in the first question. Okay, now the first thing is to solve the x-intercept. I'm gonna rewrite the equation over here. I'm gonna say f of x is equals to x squared minus 5x minus 6. All right, now from here we're gonna solve the x-intercept first. I said we're gonna be approaching it from a sketch first perspective, so we need to find the values so that we'll be able to sketch. Okay, so the first thing we need to find is the x-intercept. So for the x-intercept, for x-int, let y be equal to 0. This means that where you see y, you're gonna substitute 0, but I'm sure you already knew that. It's 0 is equals to x squared minus 5x minus 6. Okay, and then we're gonna factorize that. We're gonna have x on this side, x on this side. We need two factors that add up to make 5, but when you multiply them they give you 6. Obviously it will be 6 and 1 minus plus, let me just say plus in here. Okay, and then it will be x minus 6 is equals to 0, or x plus 1 is equals to 0. Therefore x will be equals to 6, or x, sorry I forgot the one there, x will be equals to -1. Okay, and then let's just name this x-intercepts because of it will be very useful to just note them out. Let's just say the first one will be a. We'll just call a the one with 6. It's 6 and 0, and then the other one will be b. B will be -1 and 0. And then we're gonna go for the y-intercept. So we're gonna say for y-int, let x be equals to 0. Some other people prefer writing it in this format: y is equals to x squared minus 5x minus 6, then substituting 0, 0 is equals to, while writing y, and then 0 minus 6, and then you're just gonna say it's negative 6. Or you can approach it from this view and say f of 0 is equals to 0 squared minus 5 into 0 minus 6, which is also going to result in negative 6 at the end. So we'll just call the the y-intercept c, okay? So we'll just call it 0 and negative 6. We'll just call it c, okay? Right, and then when we go forward, we're now going to solve for the turning point. I'm just going to call it TP to summarize it, TP. And we know that the turning point has an X and a Y value, okay? So to find the X value of a turning point, we use the equation X is equals to negative B over 2A. And then we substitute from there, negative B minus into negative 5 over 2 into 1. Therefore, it will give us 5 over 2, the overall answer. Okay, so now we know that the turning point, TP, it has the x coordinate of 5 over 2. Then we're going to take that very same x coordinate and substitute it back into our parent equation. That equation, the parabolic equation that we were given, it was f of x is equals to x squared minus 5x minus 6. So now we're going to substitute in that equation. It's going to be f of 5 over 2. Then we're going to substitute 5 over 2 there, squared minus 5 into 5 over 2 minus 6. This will give us an overall of negative 49 over 4. Okay. Right, so now we've got the turning point and we've got its x and y value. It's negative 49 over 4. So remember, guys, to find the x coordinate, you use x is equals to negative b over 2a. And to find the y value of the turning point, you take that value and you substitute it back into your equation. Okay, now going forward, we just found the turning point, and okay, we'll just call it TP. No need to give it a letter, or maybe let's give it a letter. It's C, so we'll call this one D. We'll just call it coordinate D. 5 over 2 and negative 49 over 4. Right, guys, welcome back. And we were about to find the axis of symmetry. I already labeled out our given coordinates that we found. We labeled them A, B, C, D. Respectively, the A and B were the x-intercept, and the C was the y-intercept, D being the turning point. And now we are supposed to find the axis of symmetry. We can find the axis of symmetry by using the equation x is equals to negative b over 2a. But we already did this before when we were finding the turning point, if you remember. It was the x coordinate of the turning point where we used this equation. So it's safe to actually say that the axis of symmetry will be x is equivalent to 5 over 2. And then we're gonna move on to sketching. To sketch, guys, it's actually when you're in the lower grades like grade 10 and maybe 9, 8, where they still require you to use the ruler, like draw them according to scale. That's my advice. Just draw them according to scale. But as you move upward in the grades, like you have the choice to draw a perfectly good Cartesian plane, draw a very well structured function. Don't draw something that, like, I see a lot of learners just drawing with a pen and then doing that. Maybe a parabolic function ends up being like that. There's no parabolic function that's shaped like a V. No matter how narrow it is, there's always a curvature to it. That's why you have the turning point. It's not just a point where it just zaps back. You have to always show its curvy nature. That's where you're gonna get the marks. So when you sketch, your sketch should actually be, well, how do we say it? You should actually sketch properly. Like, just draw your Cartesian planes with pencils and have your parabolic function get that curvy thing about it. And right now we're gonna label out the intercepts. I'm just gonna do the arrows to signify the infinite sign, arrows, and then the right. And then a, we have a at 6 and 0, so I'll just say maybe 6 is right there. And then we have b at -1, it would be closer to the origin. We can say this is 0, and then this would be -1, and this would be 6 right there. And then they say c, I just said they say, and we are the ones who found this. It would be right there. -6, sorry. I think, okay, my mistake. It would be right here. And then for D, 5/2 and -49/4, by my estimation, it would be here. Or maybe let's just move it a bit to the right. It would be right there. And then you connect the dots. I usually just suggest going from the left to the right, and there you have it. I know mine is not perfect too, but you know, in an examination you have to like be more serious. Like, let me just extend my Cartesian plane there. You have to clearly label out the points so that you can end the marks. It's 49/4 over here, we shown 6 over there. This would be -6, so like this. If you just label them out, you know, you just show this was D, maybe this was C, maybe this is A, and this is B, and then you just start writing the values as coordinate format, you know, the way we wrote them here. You put them on your Cartesian plane, and that will earn you marks. And that's it about our sketch functions, guys. Right, and now we're gonna solve this. We're gonna actually solve for this points on this function. We have two functions over here, f of x and g of x in blue. Then we have points a, b, c up to f actually. The first thing that we should do is we should identify the points that are on the graph, know what is what and what we're gonna be doing and all that, right? Okay, now a is, we should start at a. Okay, a is the x-intercept for both functions, and it's also functioning as a point of intersection if you note that out. And we also have c as a y-intercept for the function of f. We have f as a, what do we call this, the turning point. And then we have b as the other x-intercept of the parabolic function. And then we have e as the point of intersection for both functions, another point of intersection. Okay, we should note that out, guys, like, because of it's going to be very important when we are dealing with this function, right? And we actually have these two equations there for both functions, f of x and g of x. F of x being x 2x squared minus 4x minus 6, and g of x being 2x plus 2. Right, now the first thing that we should find, I think we should go with letters, you know, solve a, b, c, d, and e, and f, and all that. Okay, now the first one, we're gonna solve for, obviously a and b are gonna go in a pair since they are x-intercepts, and we know that the parabolic function has two x-intercept, so we're gonna start solving this one. So to do that, we're gonna say f of x is equals to 2x squared minus 4x minus 6, and then we're gonna say 0 is equals to 2x squared Let me just simplify it by writing it like that, because we're solving for x, when we know when you solve for x, we let y be equals to 0. But this time we're not going to write that, because this will be based on theoretical questions, and we can't, actually you can write that if you choose, but if you don't want to, you can actually leave it out and write the statement. Okay, and then from there, I think we should divide the whole equation by 2. If we divide it by 2, it will be more simplified. Therefore, we'll have 0 is equals to x squared. Okay, this x is not good. X squared minus 2x minus 3. And then we're going to factorize that. We need 2 factors of 3. That when we add them, they give us the middle term, but when we multiply them, they give us 3. Obviously, it's 3 and 1. We're going to put x over here, minus and plus. Always pay attention to your signs, guys. Like I see a lot of people be writing fast. Oh, this is just solve for x. I've done this in question. Hey. The moment when you think you've got it, please be sure to back up and check it. Because of overconfidence, we know the result of that. We know the result of overconfidence. Okay, let's continue. Then from here, we can actually just say x is equivalent to 3, or x is equals to -1. Okay, I think we just found a and b. A will be -1 since it was on the left hand side, so it's negative, and b, I think it will be positive. It will be 3 and 0. Now let's go ahead and find C and D. C and D, which were y-intercepts respectively, D being the y-intercept for the g function and C being the y-intercept for the f function. So we can just go ahead and just write just rewrite the equation over here, and 2x squared minus 4x minus 6, then say f of 0 is equals to 2 into 0, 4 into 0, minus 6, -6. Therefore, now we know that C is actually 0 and -6. Then we go ahead and find the y-intercept for the g function. So it's going to be g of x is equals to 2x plus 2. Then I'm just going to say g of 0. Then say 2 into 0 plus 2. Therefore, it will be 2. So therefore, the coordinate d, we know it's equals to, sorry, actually should have written 0 and 2. Okay, we just found the x-intercept. Now I think we can go ahead. So what did we find? We just found C, check, and then we just found D, check, we found A, check, we found B, check. So we're left with F and E. So what comes first? Let's just go ahead and find E. Okay, so to find E is a point of intersection, right? And the point of intersection is actually represented with this term. It's when f of x is equivalent to g of x. This is the point at which these two functions share the same coordinates, meaning that if you were to go into the g function and substitute that x value, you'd find this y value, and then if you were to substitute the same x value into that other function, you'd find the same y value. This is the point of intersection, where these two values are actually, where these two functions actually have the same coordinates. Okay, now we're just going to equate the two functions. This one was 2x squared minus 4x minus 6, and then we're going to equate it to 2x plus 2. Then we're going to group them on one side to make everything simpler. Therefore, we're going to have 2x squared minus 6x minus, minus 6x minus 8 is equals to 0. I know some other people are out there like, no, why didn't you group it at first? Guys, when you go up in grades, as you transition from grade 10 to 11 to 12, you gotta develop skills as you go. But let's say, no, it's late. I'm in grade 12, but I still want to grasp it. I still want to write those steps. Let me warn you on this. My guy, don't do that. You know what you do? You go home, you pick out algebra, you get a lot of equations. You get a lot of equations so that you can develop your distributive skills, so that you can develop your associative skills. You know those little skills that you might have forgotten back then? You should develop those skills actually. If you do that, then solving these equations will just be simple. Otherwise, you can just continue with grouping and doing that. If it helps you in solving the equation, I believe in that. People should do whatever helps them to solve equations, just so long as you don't do something weird and bogus and it doesn't make sense. We just want something that's relative and it actually makes sense. Okay, but I believe that if you go back and hit that algebra a little bit more, you're gonna get good at these equations. Okay, now we're gonna go ahead and just you see it's happening again. 2 is just divisible into it's 6 and 8. Okay, we're just going to divide the whole equation by 2 by 2 by 2, and then from here we're just going to have x squared minus okay, I almost made a mistake over there. 3x minus 4 equals to 0. The reason why I say you should go back to algebra, this is the other reason again. I'm like, come on guys, how many times have we came across this equation? X squared minus 3x minus 4. It's like the go-to question that they ask in every question paper, every classwork that, like guys, if you go back to algebra, hit it one more time, you'll find that, you know what, the algebraic expressions will help you in developing far much better skills when you come across other topics like trig or other functions or other stuff or calculus or maybe other future stuff, in varsity when you're solving other equations. Just develop your algebra skill, guys. It will help you out. Okay, now we're just gonna go ahead and just factorize this. X on both sides. Okay, x, and then 2 factors of 4 again, that when we add they give us 3, but multiply they give us 4. It's still 4 and 1, and then we're gonna say minus and then plus, and then from here we can say x is equals to positive 4 or x is equals to negative 1. Right, now we just found the point of intersection, and oh, sorry, I jumped the gun right there. Okay, I didn't find the point of intersection. I only found the x coordinates of them. Okay, now we take this x coordinate and we're gonna punch them straight back into the original equations. Remember the first original equation was f of x is equals to 2x squared minus 4x minus 6. Okay, my 6 right there is bad. And then we're gonna substitute 4, and then it's gonna be 2 into 4 squared minus 4 into 4 minus 6. Okay, why do I keep writing 6 like this? And then it's gonna be equivalent to 10. Okay, and then now we know that, okay, point E is gonna be 4 and 10, the coordinates of point E. Right, and other people are like, why are you not using the other x? We already stated it. Let's go back to observation, guys. We clearly stated that A and E were the point of intersection. We already found the coordinate of A through solving for x. When we solved for x for the parabolic function, we already found the -1, which is already right here. And even though we solved right here, we still found the -1, which already confirmed our suspicion that it was the point of intersection. Okay, now we're just gonna go ahead and solve some other questions. Right, and since we just found coordinate E, we're just gonna go ahead and find the turning point, which was F. To find the turning point of the parabolic function, I'm just gonna write turning. Oh, let me not write turning point. Scratch that. I'll just say x is equivalent to -b over 2a. Then we're gonna substitute negative into then our equation. Oh, right there it is. We have -4, a is 2, and then we're gonna have -4 over 2 into 2, 4, and then we're gonna end up having 1. So we already know that for coordinate f, the x coordinate is 1. So now we need to find the y coordinate. So to find the y coordinate, as we did before, we substitute it back into our parent equation. I'm just gonna rewrite it right here. F of x, 2x squared minus 4x minus 6. Then we substitute 1. It's gonna be f of 1, 2 into 1 squared minus 4 into 1 minus 6. And then we're gonna end up having -8. So f is 1 and -8. So there, we just solved for all these coordinates A, B, C, D.